Hey physics. Okay, so we're going to work with the Van de Graaff generator some more. We're going to look back at the PyPan demonstration that we did at the beginning of the year, and we're going to look back at the Franklin's Bells demonstration we did earlier. And you guys are going to find that you have a way better understanding of what's going on now that you understand more about atomic structure and charges and electrons. So while I was prepping for this, I realized I needed to look back and really make sure that I understood how the Van de Graaff machine works. So I'm going to show you the two demos that we're looking at, and then we're going to look at the anatomy of a Van de Graaff machine and what it does and how it works. So here is the first video. Here it comes. Okay, it's 10 seconds long. We have the Van de Graaff machine, and it's turned on, and it just blasts all those aluminum pie pans off. Now, you guys probably noticed that these aluminum pie pans are aluminum, so they are made of a metal that's going to be conductive. And you guys know that there's a force of repulsion that's going on there. So what you're going to understand soon is, where do the electrons go? Like, what's going on there? What charge is happening in this Van de Graaff machine? And how does it happen? Where do the electrons go? What is really going on there? Where are the subatomic particles in the situation? Okay, so then the other thing that the other demonstration is Franklin's Bells. Now, there is one difference between this demonstration and how real Franklin's Bells would work. And that is that the Van de Graaff machine creates a positive charge. What it does is it has two combs. Actually, let me show you this because this would be helpful to see this right now. Okay, so this is a diagram of a Van de Graaff machine, and I'm going to show you what this looks like on our Van de Graaff machine too. So Van de Graaff machines have, at the top, they have a sphere, a metallic sphere that looks like this, and they have like a rubber band that rotates here. Now I want to show you inside of this, because what's going on here is that this rubber band rotates when this is turned on, and it rubs against two combs that are in the middle. Now this doesn't look like a comb, but it is. This is a steel comb, and what this does is it transfers the charge that's on the outside of this rubber band, which happens to be positive, to the outside of this metallic sphere. You'll notice that this is metal. Rubber is cool because it will develop a charge that's positive on the outside and it'll be negative on the inside. This coil here is like acrylic glass, and so that's going to help to conduct that charge. This is actually going to insulate the charge, keep it just what it is. And then at the very bottom here, where you can't see, there's another roller down there that's more like a steel or a metal. So what happens when we turn the Van de Graaff machine on is that this charge starts to build up. Really what's happening is that the roller down here that you can't see is grabbing the electrons and taking them right out into that outlet right there. If I have this wand hooked up, it's also grabbing this is another thing that has electrons in it because it's neutral right now. And when I turn this on, the electrons that are stored in this wand are going to jump from the wand to the Van de Graaff machine, causing a spark. Okay, so I want to show you here on my diagram that I found. I'm going to kind of rephrase what I just said. Okay, so the Van de Graaff machine has two rollers right here. It has a rubber band basically that and two combs. The combs are the really important part here. Okay, there's a comb down here that grabs those electrons and either puts them into a wand or puts them back into the electrical system. And there's a comb up here that grabs that positive charge and it brings it out here to the metallic sphere. Okay, yeah, so that is how that works. And I wanted to show you the other demonstration now. Oops, where did it go? Here it is. Okay, so the difference with this one, in real Franklin's Bells, when we're working with they're a way to detect that a lightning storm is coming, right? So in real Franklin's bells, the charge that is coming through the system is negative because it's a negatively charged cloud passing over. And then that lightning rod grabs those electrons and brings them down into the bells, and that's how the charge difference is set up, okay? But you can see what happens here with a positively charged Van de Graaff machine because it works the same way, just opposite charges. But let's watch this real quick. All right, so what happened there is that the charge from the Van de Graaff spreads through that wire into this can. So this can 1 now has a charge. That ball is drawn towards that can because the electrons are moving within that ball. So in this case, because this has a positive charge, those electrons are drawn to the closer side of that ball, and then that pulls them over to like try to release them. So basically in this situation, the electrons are going back out. They're going this way. They're trying to balance out that positive charge, but that positive charge just keeps coming. Okay, so then that ball hits this one, it repels, it comes over here, hits that one, and then it has that same charge as this one, it goes back and forth. So what I want you to think about and understand is, where are the electrons going? Like, what is the path of the electrons in this situation, okay? Okay, so I think that doing this slideshow is going to help you out with that. Cool. I just wanted to show you real quick. I wanted to do a demo of the Van de Graaff machine working because I told you all about it, and you would be sad if I didn't show you how it works too. So here we go. I'm going to turn it on. Where's my switch? Here it is. Okay, so this rubber band is spinning. I'm going to turn the speed up a little bit. Okay, I'm going to get this wand in my hand. We'll see if we can get a zap this time around. Ooh, did you hear that? It zapped. Let me get closer. Let me turn it up a lot so you get like a dramatic effect here. Actually, maybe what we can do, I wonder if I can make my hair stand up. Woo! It zapped me. Woo! It zapped me again. I want to see if I can show you a zap. Let me turn it up some more so I can get like a good big zap. Famous last words, right? You can hear it. You probably can't see it, but it's there. My computer is crackling, so I'm going to stop. There you go. Demonstration. I guess I'm too much of a wimp to just like put my hand on it. No, this is going to happen. I'm going to do this. Woo! It's still zapping me. Okay, my hand is on it. Let's see if we can make my hair stand up. Turn it down a little bit. Okay, hair. I can feel like a charge in my arm. Woo! So the charge is flowing through me. Woo! Zaps. But you're not able to see it very well remotely, unfortunately. Sorry about that.